Hi, welcome back to the course. In the last module, we started with the Windows Forensics Essentials by analyzing the Security Identifiers or SIDs. In Module 6, we're going to talk about the system registry, the registry Hive, the structure, and some registry root keys. Before that, here's a pre-assessment question for you. What is the most common way to access the system registry in Windows? Is it A, by the Internet Explorer web browser, or B, using the Windows Registry Editor applet, also called Regedit, or C, by opening the hard drive, or maybe D, using DD? Although it is true that we can use specialized forensic tools to access the registry, the most common way to access the system registry in Windows is by the Windows Registry applet, also called Regedit, so the answer here is B. The Windows Registry is a system-defined database in which application and system components store and retrieve configuration data. The Windows operating system provides registry APIs to retrieve, modify, or delete registry objects such as keys, values, and data. The registry contains information that Windows continually references during operation, such as profile for each user, the application installed on the computer and the type of documents that each can create, property sheet settings for folders and application icons, what hardware exists on the system, and the ports that are being used. The registry replaces most of the text-based ini files that are used in Windows 3 and MS-DOS configuration files, such as the autoexec.bat and config.sys. Although the registry is common to several Windows operating systems, there are some differences among them. For instance, in Windows 98, the registry files are named user.dat and system.dat. In Windows Millennium Edition, the registry files are named classes.dat and user.dat and system.dat. From a digital forensics point of view, the Windows registry is one of the primary targets for Windows Forensics as a treasure box including not only configurations of the operating system and user-installed applications, but also meaningful data that can be useful for identifying users' behaviors and reconstructing their past events. Windows registry analysis techniques are already generally being used in Windows Forensics. In modern Windows systems, the registry is composed of multiple registry hives, and each registry hive, there is a group of keys, subkeys, and values is actually stored into a Windows registry file, also known as a hive file, as a backup container. Each time a new user logs onto a computer, a new hive is created for that user with a separate file for the user profile. This is called the user profile hive. A user hive contains specific registry information about the user application settings, desktop, environment, network connections, and printers. The HKey users key contains user profile hives. The Windows registry has a structure similar to Windows folders and files. Each main folder is named as a hive. Each hive contains subfolders called keys. These keys contain subkeys with configuration values for each software or system component of the computer. Each key has a name consisting of one or more printable characters. Key names are not case-sensitive, and key names cannot include the / character, but any other printable character can be used. Value names and data can include the / character. The name of each subkey is unique with respect to the key that is immediately above it in the hierarchy. Key names are not localized into other languages, although values might be. The most common way to access the registry is by the Windows Registry Editor applet, also called Regedit. The HKey local machine key has the subkeys hardware, SAM, security, software, and system. Each of these keys has a subkey. For example, the hardware key has the subkeys description, device map, and resource map. The device map key has several subkeys, including video. A registry tree can be 512 levels deep. The registry can be accessed both on a live machine and an image. The supporting files for all hive except HKey current user are in the system root system32 config folder on Windows NT4, Windows 2000, Windows XP, Windows Server 2003, and Windows Vista. The supporting files for HKey current user are in the system root profiles username folder. As we can see in the table displayed, the file name extensions of the files in these folders indicate the type of data that they contain. For example, .log indicates a transaction log of changes to the keys and value entries in the Hive. .sav is a backup copy of a Hive. Also, the lack of an extension indicates that the file is a complete copy of the Hive data. Okay, here's a quick question for you. The supporting files for which Hive are stored in the system root profiles username folder? Is it A, HKeyCurrentUser, or B, HKeyCurrentConfig, or C, HKeyLocalMachine, or D, HKeyClassesRoot? If you said A, you are correct. All other Hives store the files in the folder located in system root, system32, config. A quick examination of the registry within the regedit shows that the database is built on 5 top-level keys: HKeyClassesRoot, HKeyCurrentUser, HKeyLocalMachine, HKeyUsers, and HKeyCurrentConfig. HKeyClassesRoot is dedicated to storing information of the software settings about the file system, shortcut information, or information on file associations and other user interface information. The file association information is essentially used by Windows to invoke the correct program when a file is opened using Windows Explorer. HKeyCurrentUser, sometimes abbreviated as HKeyCU, contains the root of the configuration information for the user who is currently logged on. The user's folders, screen colors, and control panel settings are stored in here. This information is associated with the user's profile and is updated as users make changes to their environments. The data is extracted from the HKeyUsers key, which contains user information for all accounts on the system. HKeyUsers contains the configuration settings for each hardware and software items in the system, corresponding to each of the users of the computer system. The information on the user's folders, user's choice of themes, colors, and control panel settings are stored here as users' profiles. As we analyzed, this Hive has a subkey for each user storing his or her user profile. HKeyUsers is sometimes abbreviated as HKU. HKeyCurrentConfig extracts data from the HKeyLocalMachine key and contains information about the hardware profile that is used by the local computer at system startup. This Hive is dynamic, meaning it is built on the run. HKeyLocalMachine contains configuration information particular to the computer for any user. This key is sometimes abbreviated as HKeyLM. On Windows NT and recent versions, this key contains 4 subkeys: SAM, Security, System, and Software, that are loaded at boot time within the respective files located in the system root system32 config folder. A 5th subkey, Hardware, is volatile and is created dynamically, and as such is not stored in a file. Okay, before finishing, here's a post-assessment question for you. Which registry key contains the root of the configuration information for the user who is currently logged on? Is it A, HKeyClassesRoot, or B, HKeyCurrentUser, or C, HKeyLocalMachine, or D, HKeyUsers? If you said B, you are correct. HKeyCurrentUser provides access to configuration data for the active user on the PC. Don't forget to check the references and supplementary material for more information on Hives and the Windows Registry. And in the next video, we are going to analyze some components of the Windows Registry and some new Hives. Hello, welcome back. In this module, we are analyzing one of the Windows Forensic Essentials, the Windows Registry. So far, we have covered the definition, the structure, and some Hives. As we studied, the Windows Registry contains a root key titled HKeyLocalMachine, or HKLM. The HKLM root key contains settings that relate to the local computer. There are 4 main subkeys under this key: SAM, Security, Software, and System. The Security Accounts Manager, or SAM, is a registry file in Windows NT and later versions. It authenticates local user logons. On a domain controller, it simply stores the administrator account from the time it was a server, which serves as the directory services restore mode recovery account. It is known that Windows computers can be configured to be in a workgroup or joined to a domain. In a workgroup, each computer holds its own SAM, which contains information about all its local users and group accounts. It stores passwords in a hashed format in lmhash and ntlmhash. Since a hash function is one way, this provides some measure of security for the storage of the passwords. The SAM registry file is located on the system at the system root in system32 config folder, but it is locked and cannot be moved or copied while Windows is running. The main function of the Security Account Manager is holding onto the password used to log on into the Windows account. When we try to log into the user account, Windows will use a series of hash algorithms to calculate a hash for the password that we just typed in. If the hash is equal to the password hash inside the SAM registry file, Windows will allow you to log in. Otherwise, we will get this error message that the username or password is incorrect. The SAM registry file is not accessible while the operating system is booted up. This is why most of Windows password cracking software comes as a bootable ISO image. If we copy the SAM file to external media, then we will be able to crack the password stored in the SAM file with specialized tools such as SAM parse or offcrack. But it usually takes a very long time to crack a password, especially if the password is long and complicated. The security key contains information about local security and user rights. A copy of the SAM key is also found in the security key. As with SAM, the security key is not accessible using resource editors, and again is best managed using administrator tools. Local security authority secrets are stored in an encrypted form in the Windows registry, in the HKey local machine security policy secrets key. The parent key, HKey local machine security policy, contains the additional data necessary for accessing and decrypting the secrets. LSA secrets is a special protected storage for important data used by the local security authority in Windows. LSA is designed for managing a system's local security policy, auditing, authenticating, logging users into the system, and storing private data. Users and systems sensitive data is stored in secrets. The access to all secret data is available to the system only. Originally, the secrets contained cached domain records. Later, Windows developers expanded the application area for the storage. At this moment, they can store user text passwords, service account passwords, such as those that must be run by certain users to perform certain tasks, also Internet Explorer passwords, connection passwords, SQL and Cisco passwords, system account passwords, private user data like encryption keys, and a lot more. The software subkey is the most commonly accessed registry key, as it contains the settings for Windows and the software programs installed on the computer. When a software program is installed, data is written to the software subkey to store application-specific settings. These settings are loaded into the computer memory each time the computer system starts, so that when a program is loaded by the user, they don't need to configure the program again. There are generally subkeys for each installed product in which the product stores information including preferences, configurations, most recently used file lists, and other application modifiable items. The software key contains a Windows subkey for some settings of the Windows user interface, a class F subkey containing all registered associations for file extensions, and a policy subkey as organized by vendor for enforcing general usage policies on application and system services, including the central certificate store used for authenticating, authorizing, or disallowing remote systems or services running outside the local network domain. System contains information about all the hardware items in the system and information about the registry itself. The Windows bootloader reads control set information from the registry key HKey local machine system, which is stored at the system root system32 config system so that the kernel can determine which device drivers need to be loaded during the startup. Typically, several control sets exist, with the actual number depending on how often system configuration settings change. The kernel creates the registry key, HKey local machine hardware, which contains the hardware data collected at system startup. Windows supports an extensive set of devices, with additional drivers provided by hardware manufacturers. Drivers are kernel mode features required by devices to function within an operating system. Services are features that support operating system and application functions and act as a network servers. Services can run in a different context than user applications and typically do not offer many user configurable options. For example, the print spooler service does not require a user to be logged on onto the computer to run, and functions independently of the user who is logged onto the system. Drivers generally communicate directly with a hardware device, whereas services usually communicate with hardware through drivers. Driver and service files are typically stored in the system root at system32 and in the system root at system32 drivers, and they use .exe, .sys, or DLL file name extensions. Drivers are also services. Therefore, during kernel initiation, the Windows bootloader uses the information stored in the HKey local machine, system, current control set, services, service name, registry subkeys to determine both the drivers and services to load. In the service name subkeys, the start entry specifies when to start the services. For instance, the Windows bootloader loads all the drivers for which start is 0, such as device drivers for hard disk controllers. After execution is transferred to the kernel loads drivers and services for which start is 1. Here's a quick question for you. Which key contains the settings for Windows and the programs installed on the computer? Is it A, the Security Account Manager, or B, Security Key, or maybe C, the System Key, or D, the Software Key? If you said D, you are correct. When a software program is installed, data is written to the software subkey to store application-specific settings. As usual, don't forget to check the references and supplementary material for more information, and in the next video we're going to cover some new Hives in most recent versions of Windows. Hello and welcome back to the course. As we previously studied, from a forensic analysis perspective, an analyst does not generally interact with the registry through the registry editor. An analyst will most likely interact with registry Hive files directly, through a commercial forensic analysis application, or as a result of extracting them from a file system or from an acquired image. However, it is important for the analyst to know where this file exists on the disk so that they can be retrieved and analyzed. I recommend, if you haven't watched the previous videos in this module, please pause this one and watch them for more information on where are these Hive files stored. Windows Vista and Windows 8 introduced new registry Hive files in the system root system32 config folder. New Hives include BCD or boot configuration data, ELAN or early launch anti-malware, BVI or browser-based interface, and more. Windows Vista introduces boot configuration data or BCD. This new data store serves essentially the same purpose as boot.ini. However, BCD abstracts the underlying firmware and provides a common programming interface to manipulate the boot environment for all Windows-supported computer platforms. To give you some context, when a computer is started or rebooted, it must load the operating system. The details of this process vary depending on the system's hardware and firmware and whether the system is booted from a disk drive, a network, or some other source. The data that has determined how the NT loader loaded Windows has been contained in a text file that is named boot.ini and resides on the root folder of the boot drive. boot.ini contains a separate boot entry for each version or configuration of Windows that is available to the user. If multiple configurations or versions of the operating system are available, the entry loader displays the list of boot entries to allow the user to specify which one should be loaded. It then proceeds to load the selected version of the operating system with a configuration that is based on the selected entry's boot options. BCD provides a firmware-independent mechanism for manipulating boot environment data for any type of Windows system. Windows Vista and later versions of Windows will use it to load the operating system or to run boot applications such as memory diagnostics. BCD's data store as a registry Hive cannot be accessed with the registry editor. Its manipulation requires elevated permissions. Interaction with the underlying firmware occurs in the supported BCD interfaces. For this reason, BCD stores should be accessed only through the associated tools. Early Launch Anti-Malware is a Windows 8 security technology that evaluates non-Microsoft Windows boot time, device, or application drivers for malicious code. It is the first system kernel driver that starts in Windows 8 operating mode before any third-party software or driver. As anti-malware software has become better and better at detecting runtime malware, attackers are also becoming better at creating rootkits that can hide from detection. Detecting malware that starts early in the boot cycle is a challenge that most vendors address diligently. Typically, they create system hacks that are not supported by the host operating system and can actually result in placing the computer in an unstable state. Before this, Windows had not provided a good way to detect and resolve these early boot threats. Windows 8 introduces a new feature called Secure Boot, which protects the Windows boot configuration and components and loads an early launch anti-malware driver. This driver starts before other boot starts driver and enables the evaluation of those drivers and helps the Windows kernel decide whether they should be initialized. Boot drivers are initialized based on the classification that is returned from the alarm driver, according to an initialization policy. By default, the policy initializes known good and unknown drivers, but will not initialize known bad drivers. A system administrator can specify custom policy through group policy that can prevent unknown drivers from initializing or can enable drivers that are critical to the boot process, but have been tampered with. The BBI registry file or browser-based interface check for potential sync actions such as in applications of interest with events like calendar time zone changes. This file is used with immersive applications and keeps all immersive apps licensed to the user on the host machine in sync with other machines that are trusted by the user. It also uses logged on user and time for licensing specific to users and their applications. There are two subkeys in this registry file: events, which list applications performing a sync operation, and work items, which list the actions performed for a specific application. Okay, here's a quick post-assessment question for you. In the context of the system registry, what does BCD stand for? Is it A, boot configuration data, or B, bad configuration data, or maybe C, boot calibration data, or D, binary configuration data? If you say A, you are correct. The boot configuration data was introduced in Windows Vista and is used to load the operating system or to run boot applications such as memory diagnostics. In this module, we have covered the Windows System Registry and defined it as a system-defined database in which application and system components store and retrieve configuration data. We also analyzed the structure and different registry Hive files and folders, as well as the registry root keys. If you want to know more about these topics, don't forget to check the references and supplementary material, and join me in the next module where we will be studying the analysis of the evidence, where to look and how to perform it, and some tools that can be used. Hi, welcome back! In this lab, we're going to learn how to extract data and information from the system registry by using the Access Data Forensic Toolkit, which can scan a hard drive, a file, or an image looking for various information. For this lab, you will need a Windows operating system environment, a web browser, and you will also need the latest version of Access Data FTK Imager and Access Data Registry Viewer installed on your computer. First, log in into your Windows machine and open a web browser. I have in here Google Chrome running on a Windows 10 environment. Search for Access Data FTK Imager and Access Data Registry Viewer, or you can go directly to the link in the guide. In the website, you will be able to download and install the tools required. Remember, we need to install Registry Viewer and FTK Imager. You may need to provide some information like name and email in order to download the tools. The installation is pretty straightforward. You just need to follow the wizard, agree with the terms, and click on Next. That is why I'm skipping this step, as I already have the tools installed. Open Access Data FTK Imager. This is the most widely used standalone disk imaging program to extract the Windows registry from a computer. Click on the Add Evidence item button and select Logical Drive to extract data from a partition. We can extract data from the hard drive by clicking Physical Drive. We can also extract data from an image file or a folder. Select the source drive. In my case, I'm selecting the C drive of my computer to extract the local registry. Expand the evidence tree. Wait for the scan to finish and go to Windows System32 Config. In here, we can see the registry Hives supporting files. As we analyzed in the previous videos, the Windows registry contains a root key titled HKey local machine, which contains settings that relate to the local computer. There are 4 main subkeys under this key: SAM, Security, Software, and System, which we can see in here. We can also see the new registry Hive, such as the Early Launch Anti-Malware or ELAM and the Browser-Based Interface or BBI. You may want to watch the previous videos in this module to see the definition of each Hive. To export a file, right-click on it and select Export Files. We are going to export the SAM file, as we know that it contains information about Windows accounts. To open the file exported, open Access Data Registry Viewer. Drag and drop the SAM file into the application. We will see the registry keys related to this Hive, with information about the Windows users and groups in a hashed format. Feel free to explore the rest of the Registry Hive and learn what we can find on them. Don't forget to check the references and supplementals for more information. In the next module, we will talk about some important information to look for when analyzing the evidence.